Okay, so we're back to VEX VR. Today we will be navigating a maze. Before we do that, let's review a little bit what each of the block shapes mean. First of all, we have the hat blocks, which are represented by a big dome on top. We see this with the when started block because this one starts everything. Nothing else can be above it or before it as far as blocks. So because this is the one that starts at all, it has no interaction with anything that can stack be above it. Next, we have the stack blocks. We see these a lot with in our drivetrain category or looks category or controls category, and these are basically blocks that can be stacked one on top of the other in sequence, and for the most part, you can change the values inside of it. All the way at the bottom, we have the C blocks, which are in the control category. And these C blocks are generally loops that can either be repeated, go on forever, or loops that contain if then statements or any other conditions that need to be based as true or false. In the third row, we see Boolean blocks. Boolean blocks are what we're going to be talking about today, and these are conditional blocks that either return a true or false, a yes or no. These generally are hexagonal and light blue, and they fit inside of a C block that contains a similar shape opening. We will not be talking about reporter blocks. Those will be for a later date. Sense, think, act, decision loops, we see all the time. We do them all the time as humans, but for the most part, machines, computers, anything that's automated works on this decision loop. For example, when you put your hand close to the fire, the nerve endings in your hand begin to sense the environment as way too hot. And so a signal goes to your brain through your nervous system where a decision is made based on your experiences, and your body automatically acts by contracting muscles to pull your hand out of the fire. Computers, machines do this all the time. You might have noticed that at, at the stores, when you walk in, the doors automatically open for you. It's not magic. That is another sense think act decision loop where the sensor senses you in front of the door, makes a decision based on anything that has been programmed into that machine, and then acts according to that thinking, meaning that meaning that the door will then open for you. Our VR robot uses sensors to collect data from the surroundings, which is the sensing portion. This is what the sensors are for. It makes a decision based on this information. This is where your coding comes in, and it turns information into instructions for behaviors. This is your output. Our virtual robot has several sensors already included. It has a down eye, which senses color values. It has a gyroscope on top, which sensors degrees. It has a distance sensor in the front, which acts similar to echolocation. And it has two bumper sensors, one on the right, one on the left. These sensors act a loud bang noise near it. So these sensors work on Boolean conditions. There are three types of Boolean conditions. They are and, not, and or. Today we will talk about the or Boolean conditions. These are very straightforward. It's neither nor kind of a sentence. It could be either true or false. It can be either yes or no. Things can be off or on. Could be go or stop, up or down. These Boolean conditions will act kind of like a gate in that it will either fulfill something or not fulfill it. So today we have three vocabulary terms to consider. The first one is bumper switch. This is, as the name implies, a switch. Reports a value of either or. So it could be either true or false. It could be pressed or released. It causes a VR robot action to happen when pressed. These blue hexagonal blocks must fit into the orange Control C blocks. The second one is sensors. Sensors are they help robot interact and collect data and respond with this changing with the changing environment. For example, we have sensors in those laser thermometers that we use for checking people's temperatures. We use sensors in our smoke alarms. We use sensors on our motion activated lights outside. We use sensors for our remote controls. And the last one is Boolean conditions. Boolean conditions, uh, as I said earlier, are like gates, and they either allow or don't allow one thing to move in or out. Meaning that, kind of like a gate, it won't let move on to the next block until it's reported to be true. We will be working with wait until blocks. These are in the control C block category. It is a one line block with a hexagon shaped gray area. These Boolean conditions control the project flow. A project will not move to the next block in the stack until a condition in the wait until block reports as true, meaning that unless something happens to it that becomes true, then it will move on to the next line over. Inside of these wait until blocks, we are going to need a pressing bumper block. There are many types of sensors, but today we will be working with the bumper sensor, and the block that goes with it is the pressing bumper. You can select either left bumper or right bumper. These Boolean blocks report if a bumper switch is pressed or if it hasn't been pressed. So in this example, we see in the sensing category, we can find our left bumper pressed bumper sensing control. On the left-hand side, we see when started, drive forward. This means that when we press the start button, our robot will continue to drive forward. It will wait and wait and wait and wait until the left bumper is pressed. If that left bumper is not pressed, it is considered to be false, and the vehicle will continue to drive and drive and drive. Once that left bumper is pressed, it's considered to be true, and then it can move on to the next line of code, which is to stop driving. How does that look? So we have our when started, and in the wall maze playground, we see that our robot is down here at 6 o'clock in the middle at the bottom. It will continue to drive forward until it hits that wall. We're going to have our robot drive forward. So we bring in our drive forward, not drive forward for millimeters, but just drive forward. We go to our commands, and about halfway through, we see our wait until block. Having this block in here is not going to do anything until we have our from the sensing, our um, left bumper pressed block. Notice how this hexagonal shape fits in there. Anything other than that will not fit. For example, if I have this timer in seconds, but it's not a hexagonal shape, it's not going to fit in there, nor will another type of stacking block. So once we have our left bumper pressed block in here, we can go ahead and tell the computer that the next step that we want is for our robot to stop driving. So now we can go ahead and press play. And we see the robot move up And as soon as it hits, it stops. We can look at it from another angle where the robot moves forward, hits the wall, and stops based on the commands that we've given it. We can change this instead of stopping to turning left for 90 degrees so we can see the action itself. So what we're going to see is when we press start, the vehicle will drive forward, drive forward, drive forward, and it'll continue driving. So our block is waiting until the bumper is hit, until the bumper is pressed, and at that point it will stop driving and turn left for 90 degrees. Again, when we press start, the vehicle will drive forward until the bumper is pressed and then turn left. And that is how we use these Boolean conditions for OR.